Hello everyone. In this video, I'm going to explain how to solve the following question. In this question, we have a consumer who consumes good X and good Y. His preferences over these two goods are represented by this utility function, which is the utility equal to X times Y. We know the prices of the two goods. They are 6 and 15 respectively. And this person, who is Terry, has a total income of 137, and we want to find the best affordable bundle for him. How do we do that? Well, before we get down to the details, let's look at a graph. Here is a graph of the consumer's problem. These curves are his indifference curves, and it's drawn according to his utility function. This triangle is his budget line. That tells us what bundles are available to him. Terry, this person, tries to reach the highest possible indifference curve because the higher the indifference curve is, the happier he is. And we can see that bundle N is his best affordable bundle. It's the highest possible indifference curve that he can reach, and it's still within his budget set. How do we locate this point? Well, we can use two conditions. The first condition is that this indifference curve is tangent to the budget line. In other words, the slope of the indifference curve and the slope of the budget line are equal to each other. That's the first condition, tangency condition. And the second condition is very easy. It says that this point must be on the budget line. In other words, this person exhausts all his income on these two goods. Alright, so we use two conditions to locate this point, the tangency condition and the budget constraint. Let's go back to our question. First, let's write down the tangency condition. Suppose XY is the best affordable bundle, then the slope of the indifference curve must be equal to the slope of the budget line at this point. That makes sense. In symbols, we have this, the slope of the indifference curve, which is MUX over MUY. That's a long story. We're not going to talk about this here. And the slope of the budget line is PX over PY, which we discussed in class. Right? If you need a few seconds to digest this condition, please stop here and think about this for a while. Oh, I hope you don't have any problem. So we can go ahead. We can solve for MUX and MUY. MUX, that's the marginal utility of good X. Well, we have done this many times. It's just equal to the change in the utility divided by the change in good X, keeping Y constant. And this is a math question. The answer is Y. Likewise, the marginal utility of good Y is equal to X. Just want to remind you, delta is an operator. Okay, here this is equal to X, not because we cross out delta X. It's not like that. Although that idea gives us the same answer, but it's not right. Anyway, now we have MUX and MUY. Now let's plug in the prices. We know the prices, right? They are given. It's here. So let's plug in the prices. Well, we plug in the prices. Well, here maybe I should have put Y over X on the left side because that's the MUX over MUY thing. Anyway, no matter what we do here, we're going to get this. Okay, Y is equal to 6 over 15 times X. That's all we can get out of this tangency condition, and we'll just leave it like this here, and we're going to exploit the budget equation. What's the budget equation? It's pretty easy. It's equal to px times x plus py times y equal to income. In other words, the expenditure on good x plus the expenditure on good y is equal to the total income. Remember, 6 is the price of good x, and 15 is the price of good y. Right. Now let's plug in this tangency condition into this budget equation. That's what we're going to do in step 3. So the tangency condition tells us this. We plugged it into the budget constraint, and if we solve this equation, we have x equal to 11.42. I've rounded this to 2 decimal places. You may get a slightly different answer. And then now we can solve for y. Remember, y is equal to this. Okay. Of course, you can also plug x into the budget constraint to solve for y, but this is more straightforward. And now we're done. So the optimal bundle for the consumer is 11.42 and 4.57.